Now, without wasting time, we will continue from where we stopped in part 15. This is part 16. Question number 11. This is where we stopped in part 15. A boy standing some distance from the foot of a tall cliff claps his hands and hears an echo 0.5 seconds later. If the speed of sound is 340 meters per second, how far is he from the cliff? Let's look at this formula. A boy standing, let me take the question again. Foot of a tall cliff, claps his hand and hears the echo 0.5 seconds later. If that is the velocity is 2 times distance over time, and velocity is 340 meters per second, and time is 0.5. You can see they were given to you. Okay, then the distance is what? What is the distance? The question is, if the speed, how far is he from the cliff? By how far, it means distance. So it will, you can already substitute these values. I'm looking at D. When you make D the subject of the formula, you will get 2D over T, right? So we have 340 times 0.5 over 2, right? Because you made D the subject of the formula, giving you 85 meters. I hope you looked at it very well. Can you see it? Can you see it? Let me give you the question again. A boy standing some distance from the foot of a tall cliff claps his hand and hears an echo 0.5 seconds later. If the speed of sound is 340 meters per second, how far is he from the cliff? By now, I want to believe that you already understood how we were able to get this answer, 85 meters. Remember that what you are watching is part 16. We started from part 1 doing videos, Expo questions, past question and answer, expected questions, revealed questions, and I've been very serious. If I were you, I will ask for the link from part 1, part 2, part 3. You can ask me in the comment section and I could give it to you if you're a member of our YouTube channel. Which of the following is not a vector quantity? You know we have vectors and scalars, right? I gave you an assignment on it in a previous video, so I won't repeat it. Which of the following is not a vector quantity? A. Momentum. B. Force. C. Temperature. D. Displacement. Okay, the answer is C. Temperature is not a vector quantity. Okay, let me give you. Vector quantities are physical quantities characterized by the presence of both magnitude and direction. I have explained this earlier. Vector quantities has both magnitude and direction. Examples of vector quantities are displacement, force, torque, momentum, temperature, volume, velocity, etc. Scalars are physical quantities that is completely described by its magnitude. Examples are speed, density, volume, energy, mass, time, etc. Okay, I want to believe you've learned that one. Let's look at this calculation. Calculate the heat energy. Calculate. I want to believe you have your pen and your paper with your calculator. Remember, in JAMB exam, you cannot enter the exam hall with scientific calculator. So it is just normal market woman calculator that will be in your computer screen that you can use. So factor that in as you are preparing. And that is why JAMB always sets few calculation questions in physics, chemistry, right? Okay. Calculate the heat energy required to vaporize 50 grams of water initially at 80 degrees centigrade if the specific heat capacity of water is 4.23. Specific latent heat of vaporization of water is 22,260 joules. Okay? Look at this question. Oh. Calculate the heat required to vaporize 50 grams of water initially at 80 degrees Celsius if the specific heat capacity of water is 4.23. Okay, we look at the solving. H equals to MC, change in temperature, plus ml. Just take your time. I find it difficult to really explain because you are not watching the one we did on the whiteboard. Okay, now this is the formula. You can solve it out on your own. Remember, if I were you, all these topics that you see me getting questions from, remember to go over to your textbook and really dwell on them. Do you understand? Of course, watching these videos I make are so crucial, but then I've always repeated that you on your own must be extremely serious with your studies. You must be digging it out on your own. Spend hours. If you are reading for 30 minutes, you are joking. I've told you, now that the exam is closed, you should be drinking 6 hours of reading every day. Hit bomber to fender 6 hours, 2 hours in the morning, 2 hours in the afternoon, and 2 hours at night. JAMB is not jamboree exam. It's so important. Okay, in a series, this is question 14, in a series RLC circuit at resonance, the voltages across the resistors and the inductors are 30 and 40 volts respectively. What is the voltage across the capacitors? At resonance, you already know that SL, and the one at SL, the voltage at the one at the inductor and the one at the capacitor will be the same. Since we have 40 volts at the inductor, then we will also have 40 volts at the capacitor. That is why B is 40. There is nothing much to solve here. If the frequency of an emitted X-ray is 1.6, I just need you to probably write these formulas down and the questions down and revise on your book, right? If the frequency of an emitted X-ray is 1.6 times 10 power 16 Hertz, the accelerating potential is dash. See the formula. V equals to W over E equals to HF over E. Take your time and work it out. If the fraction of the atom of a radioactive material left after 120 years, you know, I've also always told you to study radioactivity. JAMB will jam you with questions from that topic. These topics I am mentioning, ensure you sit yourself down and read them up. If the fraction of the atoms of radioactive material left after 120 years is 1 over 64, what is the half-life of the material? Just go ahead and study half-life. Okay, now we are giving fraction of the atom left as 1 over 64. So, of course, when you factorize 64, you have 2 over 6. Okay? So you have 122 over 6 equals to basically 20 years. 20 years. 20 years. 20 years. Question 17. Anyone you don't understand, you can ask me in the comment section. A certain radioactive source emits radiation that was found to be deflected by both magnetic and electric field. The radiation is dash. A certain radioactive, just read up radioactivity, maybe I've mentioned it. A certain radioactive force, a certain radioactive source emits radiation. A certain radioactive source emits radiation that was found to be deflected by both magnetic and electric fields. The radiation is dash. A, beta rays. B, gamma rays. C, X rays. D, ultraviolet rays. Let me take it again. A certain radioactive source emits radiation that was found to be deflected by both magnetic and electric fields. The radiation is dash. A, beta rays. B, gamma rays, C, S rays, D, ultraviolet rays? The answer is A. The answer is the one that can be deflected by both magnetic and electric field is A, beta rays. Now, pay attention. We have done a lot of videos on physics, starting from part 1, part 2, part 3. Now you are watching part 16. If I were you, I will ask for all the videos we've done, starting from part 1. If you need them, just tell me, sir, please give me all the videos you've done on physics. If you also need all the videos we've done on use of English, chemistry, mathematics, biology, economics, government, and all the rest, you are free to ask for it in the comment section, and we'll give it to you for those of you that are members of our channel. If you want to be a member, let me know. You have to be a member to receive anything from us. Because alpha is positively charged and beta is negatively charged, they are deflected in an electric or magnetic field, whereas gamma radiation are not charged and as a result do not deflect in an electric or magnetic field. So the ones that can be deflected in an electric or magnetic field is either alpha rays or beta rays. Look at this question. The inner diameter of a test tube can be measured accurately using a dash. You know you cannot actually go inside the diameter, right? Inside the test tube to measure its diameter. But there is a material that can be used for its measurement. These questions are real JAMB questions, so I need you to pay more attention to them. The inner diameter of a test tube can be measured accurately using a dash. A, micrometer screw gauge. B, pair of dividers. C, meter rule. D, pair of vernier calipers. This is simple now. It is vernier calipers are used to measure the internal and external diameter of a tube. There is one you can use a meter rule to measure, but when it comes to inside a tube, that is where vernier calipers comes to the party. Look at this question 19, calculation question. Two bodies have masses in the ratio of 3:1. Two bodies have masses in the ratio of 3:1. They experience forces which impact to them acceleration in the ratio of 2:9 respectively. So the one that has mass of 3 in the ratio is now having acceleration of 2 in the ratio 2, and the one that has mass of 1 is now having acceleration of 9 respectively. Find the ratio of forces the masses experience. Given that mass 1 over mass 2 equals to 3/1, I've taught you that an acceleration 1 and acceleration 2 is 2/9, like I said. So force, we are now saying find the ratio of the forces the mass experience. Okay, acceleration 1 will be 2 times the second acceleration divided by 9. And remember, F1 over F2 will now be what? F is mass over acceleration, so F1 over F2, you can just look at it and do the calculation. Just look at how it was solved and go over to your book and solve. What I expect from you, you don't just swallow everything I say, hook, line, and center, and jump to the next one. Take your time, study it, solve it, thresh it out. You need it more than I need it. Thresh it out before you proceed. Okay? Particles of mass 10 kg is fixed to the tip of a fan blade which rotates with angular velocity of 10 rand. If the radius of the blade is 0.2 meter, the centripetal force is dash. We are now calculating note centripetal force and read it up. particles of mass 10 kg, that is 10 power minus 2 kg, is fixed at the tip of a fan blade which rotates with angular velocity of 10 rand. If the radius of the blade is 0.2 meters, the centripetal force is that A 2, B 20 Newton, C 200 Newton, D 400 Newton. Okay, given that mass, they gave us the mass, they gave us the radius of the blade, right? And they gave us the angular velocity too. So we will now substitute in this formula. Remember, what we are looking for is what? The centripetal force, which is, centripetal force is always this mw square r, and we already have all the formulas, so we'll just substitute it and we'll get 20 Newton. Okay, take your time and also solve it in your own book. Look at question 21. If these videos are helpful to you, let me know in the comment section. If there's any area I've not touched you want me to focus more on, also let me know in the comment section. Remember to ask if you want all other videos we've done. You are free to do that if you're already a member of our channel. And if you want to receive free JAMB syllabus and free JAMB past question that I'm giving you free of charge, you can also ask me. A lead bullet of mass 0.05 kg is fired with a velocity of 200 meters per second into a block of mass. That's a lead bullet. They shoot it with a velocity of 200 meters per second into a block of mass 0.95 kg. Given that the lead block can move freely, the final kinetic energy after impact is dash. Remember, kinetic energy is half times mass times velocity, right? So pay attention to this formula. Now, when we come back in the next video, video 17, part 17, we will continue from this question number 21. For you to receive all just pay attention to this formula. For you to receive all those materials, to join our YouTube channel, number one, and to receive all those materials, number one, join our YouTube channel. Just click on join our YouTube channel. That is what will make you a member of our channel. If you don't know how to join, ask me in the comment section. Remember to also like this video, share this video, click on share this video on WhatsApp, share it here on YouTube, share it on Facebook. Just share the link to all your classmates. Then finally, subscribe to our YouTube channel. Once you subscribe and you need me to give you free JAMB syllabus and free JAMB past question, come under the video, this particular video, and type I have subscribed. Type what? I have subscribed. Okay. In the next video, we'll continue from question 21.